So this is a video of me going over Unit 11, Section 1. Our objectives today are to find the slope of a line that is parallel and perpendicular to an existing line, and if we're given a point in a line perpendicular or parallel to the unknown line, write the equation of the unknown line. So before we do all of this, let's talk about some general information to remind you guys of concepts you learned yesterday. So first of all, I want to remind y'all that y equals mx plus b is the formula for a line where m is equal to the slope and b is equal to the y-intercept. Next, let's talk about what slope is. Well, actually, let's back up a little bit. Here's basically a coordinate graph, and there's a line. So when we talk about this, we would talk about this is our y-intercept, and our slope has to do with our rise over our run, or our change in y over our change in x. So let's talk about what that means. So slope is equal to rise over run, which also means the change in y over the change in x. We also know that we have this slope formula, which is y2 minus y1 over x2 minus x1. When we talk about slope, it basically means the angle that this line right here is at. It's the rate of change of that line. So rise over run, this would be our slope here, which would be equal to our m, would be 1 over 1, which is 1. And our y-intercept right here would be 1. So our m would be equal to 1, and our b would be equal to 1. So if we were writing our equation here, our equation would be y is equal to, take that back, this is down 1 and over 1. My bad, down 1 and over 1. So this slope is negative 1. So that would be negative x plus 1 would be the equation of this line. With that in mind, I want to talk to you too about the slopes of these lines right here. So this line is rising from left to right. So we know this has a positive slope. Whereas this line is falling from left to right. So it has a negative slope. Now these are all things that you guys learned last year, so this is just in essence a refresher of things you did last year. So now let's talk about parallel lines, because that's what our main topic is today, is parallel lines. So parallel lines are two non-vertical lines in a plane. They're parallel if, so let's just talk about what that looks like first. So here's a graph, and if we have two parallel lines, then that means they have the same slope. But what is not the same here, if you notice, the y-intercept for these two lines is not the same. They do have the same slope, but they don't have the same y-intercept. So lines are parallel if they have the same slope in different y-intercepts. Also, any two vertical lines in a plane are parallel, and any two horizontal lines in a plane are also parallel. Common sense, right? Okay, next we're going to talk about perpendicular lines. Two non-vertical lines are perpendicular if the slope of one is the negative reciprocal of the slope of the other. So again, let's talk about this. And I'm just going to do this with the x and y axis. We know that these are right angles to each other, and they are perpendicular to each other. Now, when we talk about negative here, we're talking about changing the sign. So when we talk about negating something, we're changing the sign of it. We talk about reciprocal, we mean we're going to flip it. So these are the terms you need to keep in mind. We're going to change the sign of whatever the slope is, and we're going to flip it. So if it was, for example, let's look at this example I have here. So if it was 4, then we're going to flip it and make it 1/4, because we know that 4 is 4 over 1. When we change that, when we flip it, it becomes 1/4. And when we negate it, we change the sign of it. So it was positive, so now it becomes negative. Now here is what my son calls a hack. You can check the two slopes to see if the lines are perpendicular by multiplying the two slopes together. If they're perpendicular, the product of the slopes will be -1. So if you don't believe me, right now on your calculators, go ahead and multiply 4 up here, 4 times -1/4. And when you do that, you're going to see that your answer is -1. So anytime you want to check and see if slopes are perpendicular, you just multiply them by each other. And if you get -1 as the answer, then those slopes are perpendicular to each other. Okay, so let's go on to the next slide here. We're going to now summarize what we just learned. Parallel lines have the same slope. Perpendicular lines have negative, that means a sign change, reciprocal slopes of each other. And when it's reciprocal, it means we're flipping it. Note, if two lines are perpendicular, then the product of their slopes, the product of their slopes, it should say slopes, are -1. Okay, so now we have some examples here and we're going to work these together. So first of all, parallel slope means it's the same. So for A over B, it's still going to be over B, A over B. The perpendicular slope here, however, means we're going to flip the numerator and denominator, and then we're going to change the sign. So this one's going to be -B over A. For this next one, it's -2, so that's going to be the same here again for our parallel slope. Again, this is 2 over 1, so when we flip that one, it's going to be 1/2, and when we change the sign from a negative, it's now going to become positive. 2/3, same slope, is parallel slope, and when we flip it and change the sign, that is the perpendicular slope. Now, the one difference here when we start talking about when the slope is 0, let's talk about what that is. When the slope is 0, that is going to be a horizontal line. So I'm going to write that here, horizontal line. Now we know that when we have a horizontal line, that the perpendicular line to it is a vertical line. Now a vertical line actually has an undefined slope. And the reason for this is when a horizontal line we would represent, so for example, let me draw a little graph right here. So a horizontal line is like this. So let's say that point right there was 2. So this horizontal line would be y is equal to 2. All of our y values would be the same, so we would end up with 0 on the top. And that's why in a horizontal line our slope is 0. However, when we have a vertical line like this, again, let's say that this was the point 2 here, and this is our graph here. So when we do this, we would have more than one 2 there. So this would now be our y value, our x value. So remember, in this case, we would have, let's just say we use this point here and this point here, and we'll say this is 2, 2, and that this was 2, 0, okay? So when we do this, our change in y is going to be 0 minus 2, whereas our change in x is going to be 2 minus 2. Well, if you put this in the calculator, it's going to be -2 divided by 0, and when we divide by 0, we get an error message on our calculator. So when we get an error message on our calculator, that tells us that the slope is undefined. And the undefined slope of a line means that the line is a vertical line. So over here, we talked about a horizontal line is y is equal to, that's what a horizontal line is, which means also the flip of that is true. So here, this would be y is equal to some number, right? This one is going to be x is equal to some number. So those are our horizontal and vertical lines. Again, refresher of what we did in the past. So let's answer this question down here. Are the following lines parallel, perpendicular, or neither? Okay, so we need to look at these slopes here. So this is y is equal to 2x minus 5 and y is equal to 2x plus 3. I notice that the slope here is 2 and the slope here is 2. So if our slopes are the same, then the lines are parallel. For this problem down here, it's y is equal to 1/2 x minus 4 and y is equal to -2x plus 8. So for the slope here, it's 1/2 and the slope here is -2. Because one of them's 1/2 and the other one's -2, they're negative reciprocals of each other, so they're perpendicular. And again, we could do our hack here. 1/2 times -2, that would give us -1, and that indicates to us that the slopes of these lines are perpendicular. So now, the next part of this, what we're going to do is we're going to put each of these equations in y is equal to form. So that means y is equal to mx plus b. So when we do that first, we're going to subtract 3x from both sides. We're going to divide everything by -4. That gives us y is equal to 3x minus 3, where 3x is our slope and negative 3 is our y-intercept. Okay, next problem, same thing. So this time we're going to add the 2x to both sides. And we're going to divide by 7 because we got 7 left over here, so we got to get y by itself. So here again, we've got y is equal to 2 over 7x plus 4. All right, so the next question here says we're going to write the equation of a line in slope-intercept form that passes through this point, negative 6, negative 9, and is parallel to the line 2x minus y equals 6. So this term right here is really important because that tells us what the slope is going to be to our new line. So what we need to do is take this line right here and we need to put it in y-intercept form. So we're going to do that first. So we're going to subtract 2x from both sides. Now this time we have a negative y. So that's really a negative 1, divide both sides by negative 1, and that's going to change all our signs. So now what we're going to do is pull this slope from this line. So m is equal to 2. The next thing we're going to do is find, so we have the slope, and we're going to use that to find, to put that into the equation for our new line, but we're also got to find b now, a new b. So if you notice we have negative 6, negative 9 here, so that's our x and that's our y, and we have our m here. So if we put y, m, and x in here, the only variable we'll have left is our b, and that's what we're actually going to solve for. So we're going to put our m, our x, and our y in that equation. When we do that, we get negative 9 equals 2 times negative 6 plus b. We're going to multiply this 2 times negative 6. That gives us negative 12. And then we're going to add that 12 to both sides. And negative 9 plus 12 is 3. So now, with these two values, our m and our b, we're going to plug those back into our equation. Y is equal to mx plus b, where m is equal to 2 and b is equal to 3. And that's going to give the new equation here that is parallel. We know it's parallel because the slope over here is 2 and the new slope is 2, through the point negative 6, 9. That's how we got our new b, is because we plugged in this point right here. So that's what enables us to write the equation for the new line. So the next problem is similar. It's one main difference here, is that we're talking about perpendicular. So our process is very similar. So we are again going to solve, put the equation in y-intercept form. So we're going to move the 3x by subtracting it, and we're going to divide by 4. Now if you notice, we got a negative 3 over a 4 here. When we do that, the term is going to be negative. If we have a negative over a negative, the term becomes positive. So if one of these terms is negative, then the term stays negative. If both terms are negative, then it turns positive. So this would end up being negative 3/4 here. 12 divided by 4 is 3. So again, this time we have negative 3/4 x equals 3. So our slope of the original line is negative 3/4. Now what we need to find is the slope of the perpendicular line. Now what we learned earlier was that we flip these numbers. So when we flip 3/4, we get 4/3, and if it was negative, it becomes positive. So our new slope, our perpendicular slope, is 4/3. Now that is the slope that we're going to use now to plug back into the equation y is equal to mx plus b with this x of 7 and that y of 1. So we've got 4/3 now as our slope. We've got 7 and we've got 1. And we're going to plug these back into that equation. So we're going to put 1 in for y, 4/3 in for m, 7 in for x. Once we do this, we're going to multiply 4 times 7. That gives us 28 over 3 plus b, and that's equal to 1. Now, what I typically do with this is give them a common denominator. So I know that 1 is equal to 3 over 3. So then I'm going to subtract the negative, I'm going to subtract 28 over 3. So that's going to give me negative 25 over 3. Now, if fractions freak you out and you can't handle it, then just do 1 minus 28 over 3 in your calculator. It's going to give you 8.33333. And if you want to put it back in fraction form, actually negative 8.33333, just push math in 1 and it'll put it back in this form. So don't let it stress you out. Just do it the way you would do any other problem. Just put this in parentheses, minus 28 over 3. It's going to give you minus 8.3333. Push math in 1 and it'll put it back in this fraction form. So now we have our slope, 4/3 here, and our new b, and we're going to plug those back into this equation, y is equal to mx plus b. So we're going to put our m here, which is 4/3, and our b there, which is negative 25/3. That's going to give us y is equal to 4/3 x minus 25/3. Okay, so now I want you guys to go ahead and do the next two check it outs and then come back to me when you're done. Okay, so now, once again, our first step is going to put this in y equals mx plus b format, which is y-intercept format. So we're going to subtract the 5x from both sides. This time we're going to divide by -2. So the -2's go away here. We got y left, and we're going to have -5 over -2, which is going to become positive, again, because both of them are negative. When we divide 8 by -2, we get -4. So our slope here is 5/2. And again, we're looking for a parallel line. Y'all see this right here? Parallel line. So we're going to keep that slope. So m is equal to 5/2. Once again, we're going to use our equation y is equal to mx plus b. We're going to put this x in, -2, that y in, 3, and we're going to put this slope, 5/2, into that equation, and we're going to solve for b and get a new b. So when we do that, we get 3 is equal to 5/2 times -2 plus b. Here's a good hack for y'all. When I have a 2 in the numerator and the denominator, I can cancel them out, so that's going to end up being -5 there. So 3 is equal to -5 plus b. Got to add 5 to both sides. So b is equal to 8. So this is our slope, 5/2. This is our new b. So we are now going to plug those back into the equation. And when we do that, we put 5/2 up where the m is, and we put 8 where the b is. We get 5/2 x equals, y is equal to 5/2 x plus 8. Okay, go ahead and do this one and then come back to me. All right, so now, once again, we're going to put this in y-intercept form. So we're going to move the 4x. We're going to divide by 2. When we divide -4 by 2, we get -2. When we divide 10 by 2, we get 5. So our slope here is -2. Again, notice here this word, perpendicular, very important. So that means we're going to change our slope by doing the negative reciprocal of -2. So it was negative, so we know it becomes positive. The reciprocal of 2 is 1/2. So this is going to become a positive 1/2. Once again, we're going to plug in our x, our y, and our m into the equation. So we have our m is 1/2. That's our perpendicular slope. Our x was 4, our y was -10. Plug these into the equation. 1/2 of 4 is 2. When we subtract that 2, we get -12. So again, we have our slope 1/2 and our b, our new b, which is -12. We're going to plug those back into that equation. Y is equal to 1/2 x. So y is equal to mx plus b. So now we have, this should be y right here, y'all. No, sorry. Y is equal to 1/2 x minus 12. All right, so next thing I want you guys to do is plot these points. Plot A, B, C, and D. Now, once you have them plotted, I want to talk through these. So first thing it asks us to do is find the slope of AD. Well, one of the ways to find the slope of AD is to count from A to D. The rise over the run. Notice over here, we got rise over run, or we can use the slope formula. So if I can put it on a graph, I'm going to do that. So we've got red to blue. That's what A is. A is red, D is blue. So we're going to go up 1, 2, and over 1, 2. So that's where I got this 2 over 2. 2 over 2 is equal to 1. Now I could use a slope formula here. When I do that, I get the same number though. The next one asks us to find the slope of BC. Now BC is yellow and green. So we're going to go from yellow to green here again. So I'm counting 1, 2 up, that's our rise. 1, 2 right, that's our run. So 2 over 2 is equal to 1 again. Once again, I could use our slope formula. Doesn't give us a different answer. Now, we're going to keep going. We're going to find the slope of AB. Now, AB is red and yellow. So we're going from red to yellow. So we're going down 1, which is a -1, and then to the right 1. So again, we got -1 over 1. That's -1. Once again, can do it with the slope formula. Then our last one is CD. So when we do CD, we're going from green to blue. So C is green and D is blue. Doesn't matter whether we do DC or CD. So I'm actually still going to do the same thing here. So I'm going down 1 and to the right 1. Now, if I did it the other way, it would be to the left 1 and up 1. Doesn't really matter. Either way, I'm going one of these is going to be negative. So whichever one is negative, it's going to end up with a -1. When we solve the formula, we also get -1. So our next thing asks us the slope of AD was 1, the slope of BC was 1, the slope of AB was -1, the slope of CD was -1. So what can you say about AD and BC? So AD and BC have the same slope and are parallel, right? What can you say about AB and CD? They have the same slope and are parallel as well. Now, what can you say about AD and CD? They actually have negative reciprocal slopes. Thus, they are perpendicular. And last one, what can you say about AB and BC? They have negative reciprocal slopes and are perpendicular. So now, what we can tell here is that this shape has right angles. And if it has 4 right angles, how do we know that there are 4 right angles? Because all the lines are perpendicular. So when all the lines are perpendicular, that means we have right angles. Right angles at this red dot, right angles at this blue dot, right angles at this green dot, right angles at this yellow dot. So if all of them have right angles, the definition of a rectangle is that it has 4 right angles or 4 90-degree angles. So that's why we know this is a rectangle.